Alrighty, I am on chapter 7. I'm going to talk to you about what ions are. Now, we have talked thoroughly about atoms, and I hope that by now you know that atoms must be neutral, that they have the same number of protons and electrons. And since they have the same number of protons and electrons, protons are positive, electrons are negative, and if you have the same number of positives that you do negatives, then you know that your overall charge is going to be neutral. And you know the job of the protons is to identify what the element is. It's so important, in fact, that it has its own number called the atomic number, and that's listed even on the chart. And that the electrons are extremely important because that's what gives the element its behavior. So we've talked about that. And it's not just the electrons that give the element its behavior. It's a specific group of electrons, and those are called the valence electrons. So that's your first word. And it's in your textbook on chapter 7 on page 187. It defines valence electrons as the electrons that are in that outermost or highest occupied energy level. That's what valence electrons are. And they are the ones that are responsible for the behavior of the element. And when you did your coloring lab, that's the ones that you colored. And so you know when you have your periodic table and you have your S block over here and you have your P block over here, these electrons, here's my S block, and here you have 6 of these over here, that these right here are your noble gases, all right? And this is my beautiful attempt at a periodic table right here. That these over here, these are your noble gases, and they are very unique, very, very unique in that they have a full outer energy level. So these have unique properties. They're extremely, extremely stable. All right, so we know that these are the noble gases, and they are what everybody strives to be. That's what they want to get to because they have such a stability, and that stability comes because their energy level is completely full. Another thing that you need to know is that the valence electrons can be found by knowing the group number. If you look at the top of each row, you're going to see that here it says on the periodic table, this is 1A, this says 2A, and this says 1, 2, 3A, and so on. These numbers are significant because they tell you how many valence electrons are in that energy level. So this whole entire row, this is the group 1A family, the alkali metals, they all have 1 electron in their outermost energy level. All of these guys right here, they all have 2 electrons. These all have 3, and so on and so on. These, except for helium, all have 8. And so there's something that's called the Octet Rule that when I'm in class with you on Wednesday or Thursday, they obey the Octet Rule, and that Octet Rule says that an atom will do anything it can so that it can achieve that octet, that 8 electrons in its outer shell. And if it needs to gain or lose electrons to get there, it will. So I'm going to take an easy one like sodium. Sodium has, let's just take 2311. This is sodium. Here's its atomic number. Here's its mass number. So we know that sodium has 11 protons. That's a number 11 right there. It has 11 electrons. And it has 12 neutrons. Oops, that's supposed to say neutrons. And you know we got that 12 by taking 23 minus 11 gives us 12. That's where that came from. All right, but let's sketch it. Okay, we know what all lives in the nucleus. Well, we know that inside the nucleus are the protons, the 11 protons and the 12 neutrons. That's what lives inside the nucleus. And what about the electrons? Where do they live? They live in these energy levels, remember. 2 of them live in this first one in an s orbital. So there they are. And then in the second energy level, 2 more of them live in another s orbital, and then if we go across, putting our finger across on the periodic table, 6 more of them live in the second energy level in the p orbitals. See, here's my little sketch of the periodic table, and now I'm on the second row. 2 of them live here, and I'm still on this second row. 6 of them live right here. So there's 1, 2, 3, 4, 5, 6. And so now, if I count these up, that's just 10. But this one has 11 electrons, so I need to have 1 more energy level. And there's that last electron, because here's sodium right here on the periodic table. If you look on your periodic table, you'll see that's where it is. It's a group 1A metal. So there I have sketched for you sodium. It's beautiful. But if it could just lose that 1 electron, if it could just lose it, it would have 10 electrons. And if you'll look at number 10 on the periodic chart, you'll see that it's neon. And neon is a coveted noble gas. And the noble gases are extremely stable.
Alex Forbes, please come to the office.
And so it would very much like to get there. If it could be like neon, it would be so happy. It would be stable. And so it's willing to sacrifice its status as an atom to become like a noble gas. Now, sodium can never turn into neon, but it can act like it if it will just lose that 1 electron. And so that's exactly what will happen. It will get rid of or transfer that electron. And in doing so, it can no longer be called an atom. Now we call it an ion because it has lost an electron. Ions are atoms that have gained or lost electrons. And if they've gained or lost electrons, now they have a charge. And since they're not neutral anymore, we can no longer call them atoms. So now we call them ions. And ions can either be positively charged if they lose electrons. If they lose electrons, electrons are negatively charged, so you're losing things that are negative. And if you lose electrons, you become more positive. Okay? And we call you a cat ion. If you're a cat lover, notice that a cat ion has that T in it, and a T looks like a plus sign. If you're a cat hater, then remember, if cats get lost, that's positive. There you go. That's a way to remember. If you gain electrons, you become negative. Negative, and you gain has that ane sound, and you become an ion. It's got that A and the N in it, an ion. Okay? That's what you're called. And if you gain electrons, you also gain a new name. When you gain electrons, your name changes to IDE. So oxygen, for example, oxygen is number 8, and it would love, 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 love to be like number 10 neon. It needs to gain 2 more, so it will. And if it gains 2 more electrons, now it's going to have a -2 charge. So it's no longer going to be called oxygen. Now it's going to be called oxide ion, because now it's an ion. And its formula is no longer just going to be a plain old O like this. It's going to be an O with a -2 charge, because it's not neutral anymore. All right? And it explains how all of this happens in your textbook on pages 188 and counting all the way through like 190. And anions are explained for you on page 192 and 193. And I am going to expect you to be able to do the problems that are there on pages 193, the practice problems, and then the section 7.1 assessment there. and you're going to have also a worksheet that shows you how. And then our next step is to learn how to write names and formulas of ionic compounds, because once you can do this, then ionic compounds, writing their names and formulas, are very easy actually. And we'll finish chapter 7 in just a minute, because we've pretty much finished it. So I hope you have a good day.